Good evening, everyone. Welcome to the last day, day four of the Generative AI Bootcamp organized by Synthrotech Solutions. So, this day of this bootcamp will be a tutorial on how to build a scale down generative pre-trained transformer model using Keras NLP. Keras NLP is basically a library designed to simplify the process of developing and training NLP models with TensorFlow or Keras. Okay, the model in this particular example or in this particular tutorial we do is used for text generation, which is trained on a small data set called SimpleBooks 92. This particular data set consists of text from several novels. Okay, so in this tutorial, we cover data preparation, tokenizer training, model building, training, and text generation. Okay, now, so there are a few setup that you have to do. So first of all, you have to install the Keras NLP package. And Keras NLP is a specialized library that provides layers, metrics, and tokenizers for NLP tasks. We saw what a token is during the very first day of the bootcamp. So a tokenizer is basically something that splits thing. Um, we'll get into it later. Okay, now we also have we have Keras NLP as well as Keras. Both of these are two different libraries. Keras is basically the core deep learning framework upgraded to ensure compatibility with Keras NLP. Okay, now we have to import a few necessary modules here. These libraries are basically crucial for handling data sets, string operations, and building the model. Okay, this TF underscore strings is basically for string operations. We have Keras NLP and Keras for building the model. We have TF underscore data for data set handling. Okay, now next is basically we have set a few hyperparameters. We are declaring them globally here so that we understand we have a variable key here so that you can refer later as well. Okay, we are not declaring each and every variable just before we use it. We have declared all the variables required here. Okay, so that it's easy. Next step, the next step that we have to do is basically data preparation. So in this section basically involves downloading the SimpleBooks 92 dataset and preparing it for training. Okay, we can see the get file function here. Yeah, here. Yeah. So what it does is we are extracting the particular dataset from the database. Okay. Now at the end of this particular code, uh, we can ensure that the data set is downloaded and extracted to a particular directory. So this is the directory where I've downloaded it. Okay, now then the training and validation data sets are loaded, filtered, batched, and shuffled. That's what is being done here. Okay, this is where batch size, min string length, and the sequence length comes in place. All those are parameters that we have defined here. Okay, yep. So just to give a small gist about what these variables are, batch size, min string length, sequence length are basically hyperparameters defining how the data is processed. Okay, now lines shorter than minimum of string length are discarded to ensure meaningful input sequences. Okay, now the next thing we have in hand is the tokenizer training. Okay, so here is where we are dealing with tokenizers. Tokenizer is trained on the training dataset to convert the text into token sequences. Okay, so we've used a variable vocab size we have which we have declared in the hyperparameter section. So what it does is it controls the number of unique tokens. Okay, now compute word piece vocabulary. This particular method compute word piece vocabulary. This particular method creates a vocabulary from the training data using the word piece algorithm. Okay, that is an NLP algorithm that we are using here, word piece. Okay, We won't be discussing the particular algorithm here. Okay. uh, we are looking at what parameters it takes, basically the semantics. Okay. Now it creates a vocabulary from the training data using the word piece algorithm, as I said. Now special tokens, like you can see, we have some special tokens here: pad, unk, bos, and these are reserved for specific purposes. We'll see what these are used for. Okay. Now next is tokenizer loading and pre-processing the vocabulary. We are loading the vocabulary then into a tokenizer. Okay. Now this word piece tokenizer converts text into token sequences. Okay. Now start and packer. You can see a start and packer method here. What this particular method does is it adds a BOS token. BOS token, we saw it is a reserved token. Okay, this particular method adds BOS token at the beginning of each sequence and ensures all sequences have the same length. Okay, pre-processing functions are then created to apply the tokenizer and packer to the dataset. Okay, that's what is being done here in this part. Okay, now next is building the model. So the model is built using several key layers. Here, going back to the hyperparameter section, you can see embed dim, feed forward dimension, num heads, num layers, vocab size, and all. Okay. Now we will be using all those variables here. Yeah. Okay. Now here the token and position embedding method. Token and position embedding method. It combines token embeddings with positional embeddings. Okay. Now we have a transformer decoder. So what this transformer decoder method does is it implements the decoder part of the transformer architecture, which is key for the GPT model. Okay. Next we have dense. Dense is basically the final output layer that predicts the next token in the sequence. Okay, the model is compiled with the loss function and metrics. That's what is being done here. We have a loss function, we have perplexity, and we are compiling it. Okay. Now, what the sparse categorical cross entropy does is it is used as a loss function since the output is a probability distribution over the vocabulary. Okay, that's why we are using sparse categorical cross entropy method. Okay, now why perplexity? Perplexity is a common metric in language modeling reflecting how well the model predicts the next token. Okay, now coming to the model training part, we are fitting the model. Now you can see a parameter called epochs. We saw this particular parameter in day 3 of this bootcamp as well, while we were implementing a variation autoencoder using the MNIST dataset, right? So epochs is basically the number of times the entire dataset is passed through the model during training. Okay, that is what epochs represent. Okay. Next is the text generation part. Here, after training, the model is used to generate text using various sampling strategies. Okay, the sampling strategies we use here are greedy search, beam search, random search, top K search, top P search. Yeah, so these are the search methods that we are using here. We'll have a small gist of what each of these search methods does. Okay, we are starting with greedy search. It selects the most likely token at each step. Okay, whereas beam search explores multiple potential sequences simultaneously to find the most likely sequence, whereas a random sampling randomly selects the next token based on the probability distribution. Okay, top K sampling, it selects the next token from the top K most likely tokens. Okay, that's how top K works. So top K is not even top K is not the optimal one. So the most optimal one will be the top P one. Okay, you can just read through this once I share this notebook in the description of the YouTube video. Okay, yeah. Now here, what we are basically doing is sampling. Okay. Now, finally, a custom callback is created to generate text at the end of each epoch during training using top case sampling. Okay, so using top case sampling, we are generating text at the end of each epoch. Each epoch means each iteration over the data set. Okay, now we'll just see what this class and all these methods are about. So TopK text generator generates and prints text after each epoch during training. Okay. Now model.fit, any machine learning engineer would know. Any person who's involved in machine learning would be would know what model.fit is. It's basically the model is trained for here you can see two epochs with the custom callback applied. Okay, yeah. So that's basically about this particular session, the text generation using GPT. So this particular tutorial, in this tutorial, we provided a step-by-step guide to building a simplified GPT model using Keras NLP. Okay, we have covered everything from data preparation and tokenizer training to model construction, training, and text generation. Okay, so this basically highlights how Keras NLP simplifies the process of building and experimenting with NLP models, making it accessible for research and educational purposes. Okay, so what you have to do to access the certificates is you just have to send a screenshot of this particular session to the Synthrotech solutions at gmail.com email ID. Okay, I'll put it in the chat box as well if you want. Okay, it will be there in the chat box, and uh, I'll post it in the live chat as well. Okay, so just send a screenshot. Okay, and we'll let you know what to do. Okay, there are some GitHub tasks that you'll have to do. Means you just have to upload the two projects that you have done to the GitHub repository. Okay, you have to fork and merge it. Okay, merge your files. So that will be known through the mail. So in order to uh, receive those mails, you have to send the screenshot of this particular session. Okay, yeah. So with that being said, we are concluding this particular session. Thank you. Thanks for tuning in. Hope it helped. If you face any doubts, you can contact us through the mail as well. Okay, we'll be replying to you. Thank you.